In this video, I want to talk about the Kansas City Hyatt Regency Atrium Walkway collapse that happened on July 17, 1981, in which 114 people died and injured over 200. Now, I have 35 years in the construction industry with a degree in civil engineering, and I want to review the cause and then give my observations and recommendations on how to avoid this from happening on future projects. Now, how did it happen? Well, the simple explanation was that two walkways, 135 foot by 8 foot and 32 tons in weight, collapsed during an early Friday evening dance and get-together at the Hyatt Regency Hotel in downtown Kansas City, Missouri. Now, let's go back a few years and start with the players involved in this project. Let's start with the owner, Don Hall Sr. Don was the son of J.C.E. Hall, who started Hallmark cards in the early 20th century. And anybody that's ever got a Hallmark card, they know what we're talking about. Their company was stationed just off the downtown area of Kansas City. Now, in the early 60s, the downtown area was becoming downtrodden. And the Halls, J.C. and Don, they decided they wanted to revitalize the area around their company. So they bought some property and they broke ground in 1968 on the first of 5 office buildings. And they started this Crown Center Shops, and then the Westin Hotel followed in 1973. In 1976, they decided that they wanted to bring in the Hyatt Regency, a big hotel development with a convention center, and so that they could draw tourists and conventioneers to the downtown Kansas City area. The project was a $50 million project with 40 stories and over 700 rooms. The convention hall connected to the hotel through this atrium, which was structural steel and composition. Now, Don contracts with Eldridge and Son General Contracting to build the hotel, as they've already built several buildings for him in the past. Now, he hires the architects and becomes a consortium named PBNDML. It's a 3-member firm consortium. Now, Don contracts directly with the structural engineer of Gillum G.C.E. rather than be employed as a sub-consultant to the architect. Now, G.C.E. engineer sublets the structural engineering to Jack Gillum and Associates. Now, I believe it's the same company, as Jack had a main office in St. Louis and a sub-satellite office in Kansas City. His engineer of record in Kansas City is a man named Daniel Duncan. Now, he's a first-year professional engineer. As I stated, also, Don contracted with Eldridge and Sons to construct the hotel and convention center. Eldridge subcontracts to Haven Steel to supply and erect the structural steel for the atrium and the walkways. Now, Haven sublets the shop drawings detailing to an outside firm, a little uncommon, as most steel companies have their own detailer. Don also contracts with Concordian Project Management as the construction managers. In my research, I believe all they did was coordinate the testing laboratories and give Don updates on the construction progress. He contracts with Marshall and Brown Inspection and General Testing Laboratories, who conduct concrete testing and bolt and weld test of the structural steel. Now, Don starts the design in 1976. He has the architects and structural engineer develop preliminary schematic drawings of the hotel, atrium, and convention hall for review and approval. After approval, the final set of construction drawings are completed in 1977. Construction starts in the spring of 1978. As the hotel is being built, Haven Steel's detailer is preparing shop drawings for the atrium walkways in January of 1979. Now, a detailer is a draftsman that takes the original engineer's drawings and draws up individual structural steel pieces that make up the atrium walkway. He shows a more detail than structural design. He'll show the actual lengths, weld connections, bolt holes, among other things on his drawings. He provides this detail work so that his steel company's fabrication shop can build each individual piece. Now, according to the plans and specifications, he must submit these shop drawings to the engineer of record, Jack Gillum and David Duncan, for review and approval. The detailer is not the engineer of record. He does not provide any engineering calculations for the work. Now, there are 3 walkways. They're 135 foot long, 8 foot wide across the atrium. And at the second floor, third floor, and fourth floor. The fourth floor walkway was placed directly over the second floor walkway, with the third floor walkway offset. Each one of these walkways weighs 32 tons and held up by 6 1¼ rods at 30-foot distance. As you look at the plan view of the walkway, you see that the outside frame design calls for W16 by 26 steel beams and W8 by 10 beams spaced equally between the I-rod supports. At the I-rod supports, he designs 2 8-inch C-channels welded together to support the I-rods. On the cross-section, he designs the top with pan steel deck with concrete. The original design called for a single continuous 1 1/4 inch rod from the atrium roof through the fourth floor walkway to the second floor walkway. The detailer, William Richard, allegedly calls David Duncan of Jack Gillum Engineers in January of 1979 and requested a change of the original design from a single-threaded 1 1/4 rod to a double rod. He states that it would be unable to thread a nut on this continuous steel rod. Therefore, he requested 2 rods. Duncan allegedly approves this change over the phone. At the trial afterwards, Duncan denies that he approved this over the phone. Nevertheless, the detailer draws up the change and submits this design to the engineer's office for approval. Now, Duncan says it's okay and just rubber stamps the change. He does no structural calculations to confirm that this redesign would be adequate for the support of these walkways. He sends the shop drawings back to Haven Steel approved. Haven Steel supplies the structural steel and erects it following this redesign. During construction in October of 1979, sections of the atrium structural steel roof collapsed. One of the connections failed on the north end of the atrium roof. Don Hall, he calls a meeting and hires an independent forensic engineer, Seaton Page, to investigate the collapse. Now, their contract dealt primarily with the investigation of the cause of the roof collapse and created no obligation to check any engineering or design work beyond the scope of that investigation and contract. Now, Jack Gillum states that he would recheck steel-to-steel connections, including the walkways, during this meeting. From October through November of 1979, Jack Gillum sends various reports to the owner and architect, assuring them the overall safety of the entire atrium, including the walkways. In addition to these reports, meetings were held between the owner, Don Hall, the architect, and Jack Gillum, structural engineers. Now, no one verifies that Jack performed the necessary engineering calculations to ensure that the roof and the walkways were indeed safe. Now, afterwards, in testimony, Jack stated that on 3 separate occasions, he requested on-site project representation during the construction phase. However, these requests were not acted on by the owner, Don Hall, due to additional costs of providing on-site inspections. And then he stated that they only spot checked some of the members as they were not getting paid for this work. In July of 1980, the construction was complete and the Kansas City Hyatt Regency Hotel was open for business. And then about a year later, on July 17th, 1981, 1,500 to 2,000 people gathered for this Tea Party dance on Friday evening. There were 50 people on the fourth floor walkway and around 100 people on the second floor walkway. 200 people were on the atrium floor under the walkways, and at 7:05 p.m. the fourth floor walkway detached and collapsed onto the second floor walkway, which then collapsed onto the atrium floor. Rescue operations commenced immediately, and in the aftermath 114 people died and over 200 people were injured. After the rescue operations are completed, the mayor of Kansas City brings in the National Bureau of Standards, NBS, to investigate. They're a part of the U.S. Department of Commerce, which is no longer in existence today. Now, they had 7 engineers investigate the collapse, and they made their findings in a 356-page report on May of 1982. They found that there was failure at the box beam hanger rod connections. NBS found that the interior tack welds on the 2 C channels were highly variable in length, location, and penetration. In some cases, there was no interior tack weld at all. They stated that the serious flaws of the revised design were compounded by the fact that both designs placed the bolts directly through a welded joint connecting 2 C channels, the weakest structural point in the box beams. The cause of the failure, they said, was insufficient load capacity at the box beam hanger rod connections. Initial failure was at the box beam hanger rod connection on the 4th floor. They also concluded that had the original hanger rod arrangement not been changed, the connection capacity would have been approximately 60% of that expected by the Kansas City Building Code. On the 4th floor, after they constructed this double rod system, the box beam hanger rod connection was only 31% of the ultimate capacity expected of a connection designed under the Kansas City Building Code. NBS also was quoted in saying that the professional engineers, Jack Gillum, issued sealed design drawings without performing critical calculations to determine whether sufficient load capacity existed. And they were also responsible when the change was from a 1-rod system to a 2-rod system. They didn't do any calculations on that redesign either. The Kansas City Permit Office becomes proactive and reorganizes the codes and inspection department within the permit office, and they form a separate administration inspection branch. Now, there was $140 million in lawsuits paid out by the insurance companies, and Don Hall and Hallmark settled for $17 million. And the courts determined that the structural engineers have full responsibility for the structural design of the project. In my assessment, you have to look at this walkway during construction when the iron workers are erecting it, and it may be similar to your project, and ask yourself, does this look right? And if you do the calculations, each walkway weighs 32 tons. There are 6 hanger rods supporting this weight. At each hanger rod connection, it's supporting 10,000 pounds of weight. And when he doubled the loading by going to a 2-rod system, the load at the 4th floor connecting rods is 20,000 pounds. So if you're a project manager, a superintendent, an iron worker, a concrete foreman, or an owner, you've got to ask the question, does this look right? You have an 1.25-inch rod threaded through 2 8-inch C channels welded together and held by a single bolt and washer. So if you're on a project and something similar and you just look at it and it doesn't look right, then have the structural engineer of record who designed it come out to the job site and review it with you. I've done it a few times throughout my 35 years in the industry, and I remember one particular time when we were building a 4-story dormitory for Bridgewater College in Bridgewater, Virginia. It was in the late 80s, and it was a 4-story structure with block and brick exterior with structural steel frame interior and pan deck concrete. Now, my superintendent at the time, he had around 35 years experience and I had around 10. And we were inside during the steel framing stage, and he asked me what I thought of the steel span between these two particular columns. It looked excessive to both of us, and so we called the structural engineer of record, and he came to the job site and he reviewed the span, and he was like, yeah, it looks more than what it should be. So he followed it up with some calculations and determined to add another column between the two spans. Now, we saw cutted the foundation, put in the pier, and erected the steel column up through all the floors. It was about a $16,000 add to the project, in which we processed as a change order to the owner. We trusted his design, but we wanted verification, and in this case, our concern resulted in additional support. Let me give you insight into why I say trust and verify with an emphatic story that may resonate with your thinking as you go forward in whatever endeavor you are in this construction industry. For me, this goes back to the Reagan presidential administration back in the 80s and the INF treaty that he negotiated with Russia. Now, INF means Intermediate Range Nuclear Forces Treaty, in which the NATO nations of Europe would eliminate nuclear missiles aimed at Russia, and that Russia would eliminate them pointed at the European nations. You see, for several decades after World War II, both the United States and Russia were in arms race to develop nuclear weapons pointed at each other. And by the 70s, each side could basically kill each other 5 times over. So the country started getting together and in the 70s to discuss it, and Ronald Reagan became president in the early 80s, and he made it his bully pulpit to reach an agreement with Russia to eliminate some of these nuclear weapons. So he then cajoles then president of the USSR, Mikhail Gorbachev, into this historic treaty. And according to the treaty, both sides would send nuclear scientists to each other's country to verify that the missiles were indeed dismantled and eliminated. And in the meetings in the White House with Mikhail Gorbachev, Reagan would spell out the treaty, and then at the end of several meetings, he would say, "We trust and verify that they have been eliminated." And then he would say, "Trust and verify," in Russian, so that Gorbachev would understand. Trust and verify. It happened in a couple of meetings, and they would be discussing eliminating particular missiles, and then towards the end of Reagan's discussion, the camera showed Gorbachev laughing, and Reagan stopped one day and asked Gorbachev, what was he laughing about? And Gorbachev said in Russian, I know, trust and verify, you say in every meeting." So since those meetings, I've used this doctrine of management in my construction company. You use trust and verify. You tend to verify everything. Why? Because these buildings that we built, that we're constructing, they are very critical. And so therefore, trust and verify has been a doctrine for me. Now, I include at the end of this video an excerpt of this historic meeting. Now, my intention is not to make light of this situation, rather to shed light and give you an excuse for verifying these critical situations on your job sites. Now, the proper format for requesting a change from the detailer in this situation where he wanted to go from a 1-rod system to a 2-rod system, he would have to ask a question, and he'd have to provide what's called a request for information. He submits this written request through the channels to Haven Steel, to the general contractor, to the construction manager, structural engineers, and the architects. The construction manager or the general contractor would then establish a sequential number for that RFI. Let's say it's RFI number 7, and it would be included in the meeting minutes for their joint meeting and also established on an RFI log. Now, I know as a construction manager or a general contractor that the structural engineer must review this change and that he would want to be paid to perform structural calculations to evaluate this change. Hopefully on this project you would have found out that Jack Gillum didn't do any structural calculations for the original design of these walkways. Maybe it was an oversight. He drew up the schematic drawings during the schematic design phase, and when he was pushed for the final contract drawings, he forgot about performing structural calculations for these members that hold up the walkways. I'll get into a subsequent separate video on the proper paperwork necessary for construction projects. Now, Kansas City mourned their dead and injured on this project as they erected a skywalk memorial for their remembrance. Don rebuilt the interior of the atrium just to have one walkway, and the hotel continues on to this day. So what do we learn from this catastrophe? Number one, qualify your design professionals. Have they done this type of work before? And have them show examples. Now, in my research, I found that Jack Gillum never designed a walkway of this kind. Number two, provide periodic inspections by the structural engineer of record. Have money in your budget for him to review the work in progress to confirm that it's in compliance with his design. Number three, provide quality control and checklist. Have a person assigned as a quality control inspector. He or she observes that the work is in compliance with the drawings and specifications and approves shop drawings and necessary applicable codes. And he or she is reviewing the work along with the city's building inspector, the architect, and the engineers. I'll get into a separate video on how we perform quality control on our projects. And then four, provide experienced and qualified construction professionals on your projects. Thank you.
Most important lessons to learn from the Hyatt is that each individual has to be responsible for what he does. Two, that you have to follow up any problems that occur. Three, that you have to have communication, up and down. You have to talk about it. You have to follow up every problem that occurs, as I said once before. That every individual has to assume responsibility for what he does, and don't assume anything. In other words, when I say don't assume anything, I mean that every individual responsible for doing something on our project cannot assume he has to check his own work. You have to check your own work. Don't assume somebody else will do it. As an engineer of record, you take the full responsibility, and that's what I did. I sealed the drawing, and that's where the buck stopped, and that's where it will on every single project.
Soviet side, over 1,500 deployed warheads will be removed, and all ground-launched intermediate-range missiles, including the SS-20s, will be destroyed. On our side, our entire complement of Pershing II and ground-launched cruise missiles, with some 400 deployed warheads, will all be destroyed. Additional backup missiles on both sides will also be destroyed. This treaty transcends numbers. We have listened to the wisdom in an old Russian maxim, and I'm sure you're familiar with it. Mr. General Secretary, though my pronunciation may give you difficulty, the maxim is dovyai no provyai, trust but verify.
Назначение этого...
На каждой встрече вы это повторяете.
You repeat that at every meeting.
I like it.
Мне нравится.